Another nice little JCB headstock repair job. So this is a non-JCB headstock. It's made as an adapter. You can see it is pulled. Those are the two main bars, the two main load carrying cross members. And they're broken right off. Probably twisted this eye a little as well. So we'll take it off, gouge it out, weld her up. Nice little machine. Fantastic bit of kit. Farm handler. This is a primary machine used for feeding the cattle on a dairy farm. So I better get my finger out and get it fixed, or same as the last time, the cows are going to go hungry. So yeah. Carnage. Absolute carnage. So I'm going to put the entire headstock into our large press and squeeze the gap closed, tack weld it, then prep it and fully weld it. So I need to be careful when impressing this not to twist the entire headstock. All we want to do is close that gap. 150 tons ought to do it. To support it so we don't twist the entire machine that way. So unfortunately this method did not go to plan, as the press did not have a hold function. It could force it back into position but would not hold it to allow me to tack weld it. So instead I decided to remove the headstock to put it on my bench for ease of preparation for welding. When I took it off the machine, the side plate fell off completely and revealed all the broken welds. I tacked it all back together, prepped all the welds for welding, and then took it up to the press in the top workshop to press the bracket on the far side, which was not detached but which was bent. So we put it on the 150 ton press, squeezed that bent bracket back down to close the gap, and welded it up. So this is me with the air arc gouger removing all of the broken welds and also creating a larger weld prep onto the plates, which will be welded to the round bar. Air arc gouger is extremely fast and efficient for this type of work, easily working into tight corners and around awkward shapes. Here's the finished result. So after the gouger, I then give everything a little clean with the grinder. This is usually minimal as the gouger leaves such a clean and ready to weld surface. So now I'm repositioning the bracket which broke off, putting it back to its original position with no gap and a large weld prep. This will ensure it will be much stronger than when it was originally put together. So you can see a gap. This is due to this lug being bent to the left, which is holding the pin up and resulting in a gap. That's why we need to take it to the hydraulic press in the top workshop, press this side down. It's more like it now. So that's it all pressed back into shape, all gouged out, prepped and ready to weld. A lot better shape than it was, so gonna put treble the amount of weld that I originally had on it and look at maybe putting an extra gusset in, but yeah, it's looking good. So I could have removed both lugs, but in the case of measurements, you always want to try and keep a reference point. So it was easier just to press it back into position and weld all of the broken welds, and any compromised welds, remove them and re-weld them. So this is me welding it up now in time lapse. Tricky little welds, lots of twisting and turning and repositioning. I'm just using solid wire on this job, mild steel. I think it was 1.2 mil diameter, which I like for a bit more penetration and fusion. It carries the power of the arc to the parent material a lot better. It's always a compromise between 1 mil and 1.2 mil. 1 mil is slightly more forgiving in tricky positions. So a lot more weld than original. Straightened out. New plate in there. confident she won't be back. So let's get her together and get her out. I can never decide whether to put music on the time-lapse sections or not, but I reckon I'm just going to waffle a bit. So yeah, we're just putting the headstock back on. This is where you get to find out if you took measurements correctly, and it was definitely a snug fit. I was delighted that it wasn't too tight or left with a gap requiring a shim, and as you can see, it just snugged up in perfectly. So we'll get the pins inserted. It's always fun trying to hold seals in place and keeping them lined up without destroying them. Seals are important to keep the dirt out of the pins and to keep the grease in. I'm spoilt with my overhead crane. It allows me to position the headstock without the machine hydraulics or in combination with the machine hydraulics. So as you can see, I just needed to tilt the linkage a little bit. Having the equipment like the overhead crane and the big hydraulic presses sure does make life a lot easier and allows me to complete these jobs a lot faster. This repair was just about a day's work, and quite happy with how it turned out. This is quite a short video. I've just sort of skimmed over the job. I hope you enjoyed it. I couldn't take an in-depth video. As always, the primary concern is to get the job done for the customer. I just try and squeeze in some footage in between. I always reckon videoing the job takes about as long as it takes a smoker to have a cigarette or less. So yeah, just skimmed over this job, and bit more mechanical footage for you guys to enjoy. So if you enjoyed it, I'd appreciate a thumbs up, and if you want to hang around for the next one, click subscribe. And if you want to see lots of stuff that doesn't make it onto my YouTube, check out my Instagram, AlistairC123. I'll put a link in the description below. And as always, guys, appreciate the support. So that's a repair done. Maybe 3 or 4 times the well of the factory. It shouldn't break again. So yeah, I hope you enjoyed that quick little repair. If you did, as usual, give me a thumbs up. Keep the channel growing. Dying to get to 100,000 views, or sorry, subscribers. So yeah, if you enjoyed the video and you want to stay on board, hang around for the next one, click that subscribe button. I'd love to get to 100,000 views, subscribers. So thanks to everybody for your support, and I'll catch you on the next one.